Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I be to all. Okay, today I with my partner will present about LED 3 pneumatic system in industrial electronic. First of all, let me introduce our group members. First, my name is Muhammad Arif Hazim bin Tajuddin. Number matrix AA190125, and my friend Luqman Hazim bin Yusri AA190631. Without wasting any time, let's go to the lab activity 1. Okay, first let we discuss about the circuit 1. When air is pumped into the system, it will enter the actuator A1 and push the piston B1 to the right. When the actuator A1 is pushed and held, no air pushing the piston B1 cause it to move to the left. When the actuator A1 is released again, the piston B1 will return to its original position. Let's go to the second circuit. When air is pumped into the system, it will be blocked at the actuator A2, causing it to be unable to enter the piston. When the actuator A2 is pressed and held, air will pass through it and enter the piston B2 and push it to the right. When the actuator A2 is released again, its piston B2 will return to its original position. And for the circuit 3 for lab activity 1 is when air is pumped into the system, it will pass through the actuator A3 and push the piston B3 to the left. When the actuator A3 is pushed, the air will push the piston B3 to the right. Even if it is released, it still remains at the position. When the actuator A3 is pressed again, it will return to its original position and the piston position B3 will return to the left. Okay, let's see the observation. Observation number 1, tabulate the list of components used in figure 1. Okay, first of all, we use compressed air supply for the 3 circuits, circuit 1, circuit 2, circuit 3, and single active cylinder. We use through 3/2 in wave valve, 5/2 in wave valve. Observation number 2, discuss the difference between the two actuators below. Okay, as you can see, for the actuator on the left, this actuator is used for piston with spring, while for the actuator on the right side is used for the piston without spring. Other than that, when we move the actuator on the left side, we need to press and hold it, while when we move the actuator on the right side, we just need to press and don't need to hold it. Let's go to the question. Number 1, describe the function of spring for components A1, A2, A3, B1 and B2. The function of spring for component A1, A2 and A3 is to move the valve to let the air through it and go to the position. The function of spring component in B1 and B2 is to retract the piston to the original position. Question number 2. Explain why B3 does not need a spring. B3 does not need a spring because the actuator in the system already help to retract the piston to the original position. When air is pumped into the system, it will pass through the actuator and push the piston to the left. When the actuator is pushed, the air will push the piston to the right. Even if it is released, it still remains in the position. When the actuator is pressed again, it will return to the original position and the piston will return to the left.
Okay, for lab activity 2, first, when air is pumped into the system, it will go through actuator A and enter B2 and go to the piston C. Nothing happened to the piston and air will go through B1 and out. Second, when actuator A is pressed and held, air will pass through it and enter B1 and push the piston C to the right and will out through B2. Third, the value of D1 and D2 will be 0.60. Okay, for the observation, discuss the effects of setting B1 and B2 10% to the operation of the pneumatic system versus when they are set to 100%. When B1 and B2 is setting to 10%, the time for D1 and D2 value becomes 0.60 is slow. When B1 and B2 is setting to 100%, the time for D1 and D2 value becomes 0.60 is fast. Okay, for the questions, discuss the function of this component below at B1 and at B2. Note that the direction of both is opposite to each other. This component is check valve. A check valve is basically a one-way valve in which the flow can run freely one way, but if the flow turns, the valve will close to protect the connection.
Okay, now let's go to the lab activity 3. When air is pumped into the system, it will be blocked from passing through the actuator A1, A2, A3. Yet air can still pass through the actuator C and enter the piston D and push it to the left. When the actuator A1, A2 is pressed, air will pass through it but will be blocked by. When the actuator A3 is pressed and held, air will pass through it and enter the actuator C, however, it will not change the position of the piston D. Let's see the observation. Describe how to activate the actuator below. To activate the actuator above, we need to press the valve to change its position, which it will move to the right and make the piston to change position. The other way to press the A3, which will also make the valve move to the left. Okay, let's go to the question. Show the component used for logic in the circuit. Okay, first component we use piston. We use pneumatically operated valve, two pressure valve, actuator A1, A2 and A3 and compressed air supply. Question number 2. State the logic function for implemented is it or and nor none it is and others. For this system, it is or logic function because to move the piston we can either press the valve C or we can press the valve A3. The last question is explain why C does not need a spring. C does not need a spring because it operates due to air supply and pressure at different ports. Either is it from right or left. This valve will operate based on the different pressure at the right part and also the left part of the valve. That's all from me. Thank you.